Okay guys, so we should be in the 2.10 notes, and each video is just going to go page by page here. So first we're going to talk about something that we've discussed previously, and then we're going to build that into what it means for a rational function. So here we have a polynomial in factored form. P of x is equal to x plus 2 times x minus 1 times x minus 5. And we just want to identify x-intercepts. Reminder that x-intercepts is the same as solutions, roots, or zeros, and we are looking for the x value that makes the answer equal 0, since every x-intercept is always the x-coordinate, comma, the answer being 0. So for the first factor, we have an x-intercept at negative 2, comma 0. For the second, we have positive 1, comma 0. And for the last one, we have positive 5. And we've been talking about this for months now, is that these are the x values that make our parentheses equal to 0. So we know by definition an x-intercept is an x value that then has an output or an answer of 0. And if any one of these factors, like the first factor for example, if you put in negative 2 plus 2 becomes 0, you multiply it by anything else, it doesn't matter, your answer is still going to be 0, which means we found an x-intercept. So when it comes to a rational function, reminder, rational function is a function that has a variable in the top and the bottom of the fraction, is that in all cases, if we have 0 divided by any number, doesn't matter what that number is, your answer is always going to be 0. Which means if your answer is 0, you have found an x-intercept for whatever x value that is. So as long as the numerator, or the top of our function, is equal to 0, we have found an x-intercept. So we will have x-intercepts at negative 3 for the first factor and positive 1 for the second factor. Now, considering the denominators, things get different, because in all cases, any number divided by 0, anything divided by 0 causes an error. And the word we've been using is undefined. So it causes a problem, which means the graph can't exist at that point. So last lesson in 2.9, we talked about asymptotes and how vertical asymptotes are whatever makes the denominator equal to 0. So we have a vertical asymptote at the line x equals 2, because 2 is the x value that makes your denominator 0, which ultimately means that your function is undefined and it can't exist at that point. Let me clean that up a little bit. Undefined. And therefore the graph can't exist there.